look at Excel and we're going to actually say, well, I'm going to build my own contingency table. So usually, like I've been showing you these really easy kind of event A and B contingency tables, right? But where do those numbers actually come from? Well, a lot of times we'll have those contingency tables, but they're going to be built from some underlying or original data. So I have this data set. Let's see, it's like all these different industries, right, in different years. And I'm looking at them and thinking about, okay, what was the union membership in those industries in that year? What is the union members' weekly earnings? What are non-union weekly earnings? And here I just created a variable which was, okay, what's the difference between union and non-union earnings? So all I did here was take union minus non-union earnings. Right? We think about with union power, hopefully these workers are usually able to bargain for larger salaries or higher wages, right? In fact, if we look at that difference variable, you know, there's a couple that are negative, but for the most part, everything's positive, right? The unions in most of these industries are actually earning more than their non-union counterparts, okay? So if I think about maybe in different industries, there's a higher percent of union members. Let's think about if I'm trying to hire a worker and 100% of the workers in that industry are in the union, well, I have to pay union wages, right? But if it's only like 10%, well, I'm not going to hire a union member because they're going to cost me more, right? They're able to bargain for higher wages, so I'm just going to hire a non-union member for a lower wage, right? So we might think about the percent of these industries that are union workers might influence what that wage differential is. If we're all union members, we can have a lot of power to bargain our wages up with these companies, okay? So we have these two variables. Now, you don't always have to do this, but just to get an idea, let's look at some averages. So the mean union membership, we'll go over here, equals average. Here's my membership. Control Shift down arrow or Command Shift down arrow on a Mac, hit Enter. All right. I'm going to do this for union earnings. Oh, which one was that? I think it was E. And then we're going to do non-union earnings, which is right here. And this is just to get an idea about what the data we're looking at. And then the average difference we'll find right here. Okay? So on average, across all these industries in these different years, about on average, an industry has 10% union members, right? And that varies from union to union, but the average is 10. Right? The difference in union non-union earnings, the average difference is about $118. Okay, so union members earn on average about $118 more. And I believe these are weekly earnings. Okay, let me get rid of this and put it up here. So I'm going to create some cutoff values here, and I don't want to use different ones, so I'll try to remember. So let's say I use the cutoff of 10, and so thinking of 10 and 100. I'm just going to put those values there for right now, and I'll kind of explain a little bit more about why and how we'll use them. So if I look here, I've set up this contingency table, and I've thought about two events. One event is the union membership above 10% in that industry? Or kind of the complement of that would be, is it below 10%? So I've essentially set up my events B and B complement. My event A, I said, is the difference in union, non-union earnings $100 or more? That's my event A, or A complement, is it less than $100? Okay? So I've set this up just like those contingency tables we had. It's just I've actually given names to what A complement, B, and B complement are. And I use these cutoffs, right? What you should be using here really just depends on what the problem is. I try to choose something around the average, so I can think about this as like industries with above average union membership, industries with below average union membership. But I just want to choose not the actual average, I just want to choose a number close to that, okay? Just to kind of make this a little bit easier to think about. So if I want to build this contingency table, what I'm thinking about is, okay, how many industries have 10% or more union membership and $100 or more differential in union, non-union wages? So I'll count the number of industries where that is true, that both of those things are true, right? A and B are true there. Once I have that frequency to turn it into a probability, Well, it's just like what we were doing essentially when we looked at frequencies and changed them to relative frequencies. All we did there was divide by the total number of observations. So those relative frequencies were really representing proportions or probabilities that we were creating based off of the data we had. So the first thing we'll do is we'll count the number of industries where both of these things are true. So we'll use something we've used already, which is that count ifs. Because essentially we want to count the number of observations where the first thing is union membership above 10%. So we'll have to select that variable. So we go over here. Our union membership variable was right here, right in column C. So I'll select that entire column, Control Shift, hit the down arrow. I got to scroll back up here, which is kind of a pain. But now that reference is there to use that whole column of data. I'll then put a comma. The next thing I need to tell it is take that variable and only count the observation if, right, union membership is greater than, right? So we'll put that in quotation marks. Put an and sign, greater than 10%, right? And then have that cutoff of 10% up here in the cell, okay? Now, that was the first thing we wanted to check to see, to count if it was true. But we wanted to count them if they had above 10% union membership and the wage differential between union and non-union members was $100 or more. So the second thing we want to do is go look at this difference variable and say, we only want to count it if that difference in earnings is greater than 100. Actually, I said 100 or more, so I actually want greater than or equal to 100. So you could select this again, but on a laptop especially, and especially if I didn't have my mouse with me, it's kind of a pain to scroll back up. Well, notice if I know the column this is in, the data is going to go from 2 to 736 as well. So I'm just going to type it in, H2 through H736. Right? You could have selected it, with your mouse or using the Control Shift, but this is for me a little bit easier, so I don't have to keep scrolling up and down. So here was the first thing I wanted to check using this variable. Now I want to use this other variable and only count it if it's greater than or equal to, right? Use the and sign. And my cutoff for the income difference was this $100 that I had up here. Okay. Close my parenthesis, and this should count the number of industries that have $100 or more difference in union, non-union member earnings and have union membership that's above 10%. Okay. So this is why I said, when we first used the count ifs formula on building the histograms, it was weird because we were selecting the same variable here. Well, we can use that count ifs when we want to check to see if two different variables meet different criteria as well. Okay. So if I hit enter here, 220 of those industries that I have in my data set meet that criteria, right? Have 10% or higher union membership or $100 more. And actually, I think I forgot my equality here, right? Because it's 10% or higher, so greater than or equal to. Now, I'll show you kind of a shortcut to filling out the rest of this table. So I could type this in, again, down here using the count ifs. Now I want to check, is it greater than or equal to 10%, and is the other variable less than 100? Well, instead of typing everything in, I'm always going to want to use the same range of data. So I'm going to freeze that. So once again, F4 or FNF4, if you're on a Mac, Command T, puts those dollar signs there. We'll do the same thing to the other variable. But also notice, my cutoff value should never change here either. So I'm actually just going to freeze these as well. Okay. Now when I copy this over, it should give me the exact same value, right? Because nothing should change here, right? Now, another thing you could have done, instead of, let me see, let me get all the dollar signs off. Let's see if it'll do this. It's probably going to yell at me. Yeah, it just doesn't like that. All right, so let's say I had it entered in without dollar signs, right? And let's say I want to copy that to the other cells. If I highlight this and then Control C, or if you just copy it, hit enter to get out of the cell. Now if I go over here and I click on that cell and I hit paste, if I use that copy paste right? It doesn't actually update my cell references. So I can do it either way. I can use that copy paste, or I could freeze everything and just drag it over and copy it that way. So I'm just going to drag this over to copy it. Also, I changed the size of my mouse, so hopefully this is a little bit easier to see me moving. So I've got the same value, but that's because I haven't changed that criteria. Because in here, what I actually want is union membership, I want to make sure we can see this, below 10%, and is that difference in earnings $100 or more. So now instead of being greater than or equal to 10%, I actually only want to count it if it's less than. Right? Now I still want to check to see if that variable of difference in earnings is greater than or equal to 100. Right? So should be okay. Now I'll hit enter. Okay, so I'll go down here. Here I want to see, is union membership greater than or equal to that 10%? So that's good. But now I want to check to see if that difference in earnings variable is less than 100. So not greater than or equal to 100 now, but less than 100. So once I copy this over, I'm basically just going through and making sure those equality or those kind of inequality signs are matching up with the row and column heading. Okay? The last one I have, I want to make sure that it's less than $100 and less than 10%. So I'll change both of these to a less than sign. Okay? Any questions on that process? So I've got my frequencies now. Right? So now how can I get the totals? Well, how did we say we do it when we had probabilities? How could I have reproduced the total column? I said you could add down the columns or across the rows, right? Think about it this way. If I want the number of industries, this total represents the number of industries with $100 or more wage differential. Right? So if I count the number of industries that have $100 or more wage differential with 10% or higher union membership, and the number of industries with $100 or more wage differential that have below 10%, well, that covers everything. I've now counted every single industry that just has $100 or more wage differential, right? They'd have to meet one of these criteria. Their union membership would either have to be 10% or higher, or it would have to be below 10%, right? So we said we could add across the rows, so I can use that sum function just to add these values up. I can then copy that down. It'll add these two up for me. And I also said to reproduce the totals down here, you can add across the rows and down the columns, right? So I'm just adding these two values up, right? With that sum function. Go over here. Now if I think about what should I be able to reproduce here, well, if I count all the, well, I'll do it this way. If I count the industries that have 10% or higher union membership, and I add to that the number of industries I have in my data set that have below 10%, that's going to count every single industry that I have in this data set. So if I add these up, these totals up here, I should end up with my total number of observations. Okay? So I hit enter, 735. How could I check that? What was a function that we used just to count the number of observations? Equals count. Yeah, same. I kind of was trying to allude to it there. We just use that count function. I go over here. I can use either variable, Control Shift, Command Shift on the Mac down arrow. Hit enter. It tells me the number of observations. My total here matches it. That's good. That means I didn't make a mistake. If I had, let's say I forgot the equality in this very first one, notice I would have been missing a couple observations. And if I use this as a check, it lets me know, okay, I made a mistake somewhere. And if I'm only a couple observations off, it probably means I made an error with the equality signs. So let's put those back in, and that was the error. Okay. Any questions on any of that right there? Okay with that? All right, let me make sure there's nothing in the chat. Okay. So, all right, this is great. What the hell are we doing? We're trying to get probabilities, and I've got all these numbers over 100, right? Well, I said if I know the number of industries that meet this criteria, to turn that into a probability, it's just 221 out of the total number of industries, out of 735. So what I'm going to do to create my contingency table is I first built this frequency table, and then I'll just take every frequency and I'll divide it by the total number of observations. Now, when I copy this over, I want K9 to become L9, but I always want that total number of observations to stay the same, so I'm gonna throw some dollar signs there and freeze it, so that will always kind of keep dividing everything by the total number of observations. So I'll copy this over, I'll copy this down, and now I've got my probabilities. That easy. Right? Once I get my frequencies, turning them into probabilities should be a pretty easy step. Now notice, hopefully when we get down here, I'm taking the total number of observations divided by the total. I should get 1 here, right? That's what I should always have. Right? So if I don't have 1 here, I made a mistake. Right? Excuse me. Any questions on that? Like I said, that shouldn't be too bad. Okay. Well, now, this gives us some probabilities to start playing around with. And just for the sake of the way these look, nope, wrong way. I'm just going to put them to 2 decimals just so it doesn't look too crazy. But the nice thing is, even though it looks like 2 decimals, it's still stored out to whatever the decimal level is. So let's say I just want the probability that an industry has 10% or higher union membership. So I would go equals, where would that be? The probability they have 10% or above union membership. So if I want the probability that's 10% or higher, what should that be? Yeah, I just remember, we go down to the total. The total columns represent the probability of whatever their column or row heading is. So the probability that someone has 10% or higher union membership in their industry, we just go down to that total, right? I could just click on that cell, hit enter. Right? Now, what if I wanted the probability of being 10% or higher and having a wage differential that's $100 or more? Okay. So what cell would that be in? Well, it's a little tricky because 10% or above, but that or is kind of within our event. So I want having 10% or higher and a wage differential of $100 or more. So wage differential of $100 or more and 10% or higher, right? My top 4 left cells, those are what represent the intersection. This and this. Okay. Or maybe I should say this and that, I don't know. So we can use this contingency table just like we were doing before, right? So let's think about some conditional probabilities. Given that I'm looking at an industry that has 10% or higher union membership, what's the probability that I see them have a $100 or more wage differential? Well, if we want a conditional probability, we said it's the intersection of these 2 events. So there, $100 or more and 10% or higher. And then we divide that by what we condition on. So what we're conditioning on is that there's a 10% or higher union membership. So the probability of that we have down here. It's kind of using these two probabilities we found earlier. Hit enter, and I get, okay, if I know that an industry has higher than 10% union membership, the probability that their union members make $100 or more than their non-union members is about 76% chance, right? Or a probability of 0.76. However, what if I say, okay, now I'm conditioning on or telling you the industry has low union membership, below 10%. Well, it's still going to be, right, it's a conditional probability. It's going to be the intersection of those 2, so $100 or more and below 10%. And I'll divide by what I'm conditioning on, which is the probability that it's below 10%. So now if I tell you that the industry has low union membership, the probability that there's $100 or more wage differential between the union and non-union members, it's fallen to only about 40%. And this is the idea that's kind of telling us that, yeah, these are, looks like these 2 things might be related because the conditional probabilities change quite a bit when I'm conditioning on these different events, right? If I know that there's more union members in an industry, they're going to have a little bit more market power. They're going to be able to have a higher likelihood of bargaining for this large wage differential. If I'm in an industry with low union membership, they don't have as much power. The probability they can bargain up to this $100 or more wage differential, not near as likely, right? What, 35% lower, actually. Okay. And you know, we could do things like check for independence here using our different methods. So, you know, for example, let's say, you know, it should be that the intersection is the same as the probability of the events multiplied by each other. So if I take 0.55 times that 0.39, the probability of $100 more wage differential times the probability of 10% or higher union membership, that should be equal to the intersection of those two events if they're independent, right? So I look there, well, that's not 0.3, so I will kind of think about these are not independent events, right? Because the product of the two events, probability of A times probability of B, is not the same as the intersection of those two. Okay. Are these events mutually exclusive? Should be able to tell me from that contingency table. Is having 10% or higher union membership and $100 more wage differential, are those mutually exclusive events? If they were mutually exclusive, what value should I see here for their intersection? 0. So are they mutually exclusive? No, because this is not 0, right? More often than not, they're not going to be. Like, mutually exclusive is somewhat rare, right? When we're looking at things. So that's kind of how we would build our own contingency table. You might be asked in the next Excel assignment, kind of after this week. I might post an Excel assignment where you have to kind of build your own, and then you're kind of asked to do some work like this, answer different questions using the values that you see in that contingency table. Okay? But really, it all starts from we're just looking at kind of frequencies and then really turning those into relative frequencies. Okay? Any questions on any of this? Do you want to see a cell again or anything there? You okay with this? All right. So I have kind of the completed sheet already uploaded. It's in the same workbook. So when you see the union data file on Canvas, we just worked like from the blank one and kind of built it. But just as a check to what we were doing, here's this final one. You can kind of go and you'll find everything that we just recreated. So even if you didn't work along with me, you've got that there. Okay. Oh, but I also wanted to mention one more thing. One thing that's kind of cool is the way I have this set up. Let's say like this was trying to get at like, you know, industries with like high union membership, having higher or above average differentials. Well, maybe I want to look like at really high union membership. So instead of 10, I'm like, well, let's look at 20, right? Really, really high union membership. If I change that cutoff, if I go back, notice it updates my frequencies, it updates all my probabilities, it updates all my work down here. So using these cell references is so useful because I can start to then play around with different cutoffs. Maybe I'm not just interested in high union membership, but really high. I don't know if I can go up to as high as 70. Yeah, I was gonna say we probably start to get zeros there. Let's see if we can do 50. 50 is still too high. There we go, we do 30, we still have some zeros. So here, we would say that having differences less than $100 or 10% above, those would actually be mutually exclusive. We end up with a probability of 0. Okay. But I can play around with these cutoffs. The other thing I could do is maybe I just said, well, I tried to choose a number near the mean, but maybe I want to use the mean as my actual kind of cutoff, having above average or having below average. So if in my cutoff, or that cell that I was referencing where I had the cutoff, what if I did equals average and then took the average union membership? So I got the average in there, it updates everything as well. So it's really nice to kind of have those initial cells where we'll put these cutoffs in instead of like typing 10 in here every time. Well, then if I want to change that, I got to go back through and retype everything. Whereas if I use cell references, I just have to change one cell. Okay. All right, I think that's the only other thing I wanted to